Hello and welcome. Thank you for joining us for today's PCWA Lunch and Learn webinar, From the Mountaintops to Your Tap. My name is Ross Branch. I'm the Public Affairs Manager for Placer County Water Agency, and we have an information-packed day for you, and we thank you for taking your lunchtime to join us. We're currently waiting for some more participants to enter the webinar. But as we do that, I'm going to go ahead and just move on to a couple of housekeeping notes. The first one is this webinar is being recorded. So if you know someone who was unable to attend live, or you want to go back and watch it again, this will be on our website. Also, there is a live transcript option available. So if you want to follow along with some closed captioning, all you need to do is click the live transcript button at the bottom of your screen. As we go through the presentation, feel free to submit questions. You'll notice at the bottom of the page, there's also a Q&A icon. If you go ahead and click on that, you can enter a question. We would ask that you share your first name and location. That way we can try to identify you if we get to your question. As I said, we do have close to over 100 participants joining us today. So I don't know if we'll get to every question, but we will do the best we can. And if you have any follow-up questions, you can always email us at info@pcwa.net, and we can try to get to your answer then. So with that out of the way, I'm going to go ahead and give you a brief overview of today's presentation. We're going to start with an overview of our water supply. Then we're going to go behind the scenes and do a video tour of our Foothill water treatment plant. We're going to follow that up with a discussion on distribution, and then we'll wrap up today's presentation with a discussion on drinking water quality testing and standards. So with that, once again, I want to go ahead and welcome you to our presentation. And we will go ahead and start with our first panelist today, who's Andy Hamilton. Andy Hamilton is the Drinking Water Operations Manager here at PCWA. And Andy, before we get kind of into the details of today's discussion, I was just hoping if you could start with a brief overview of your department and what they do.
Yeah, hi Ross, thanks for having me. So Drinking Water Operations is a division within the Technical Services Department here at PCWA. We're made up of highly intelligent, trained, certified and motivated men and women. And collectively, we're responsible for treating and distributing clean, safe, and aesthetically pleasing drinking water that meets and exceeds all of the state and federal guidelines and regulations.
Great. Now, as the title of this webinar describes, we're going to try to travel from the source of our water down all the way to the tap. Can you please talk about PCWA's water sources and what makes them unique for customers?
Sure, Ross. So first, I kind of want to take this time to clarify what a watershed is, just so that if somebody doesn't know, they can start to visualize some of this. So a watershed is basically a general geographic area divided by a ridge of land, in our case, the Sierra Mountains. So kind of think of a bowl, and that bowl is either holding or draining water out towards the ocean. In our case, it's the Pacific Ocean. We actually have two watersheds that produce water, the raw water source for us. And to make it easier to visualize for our viewers, I want to use I-80 as kind of our reference point. And to the north of I-80, we have the Yuba Bear watershed. So that starts at Lake Spalding, up in the Sierras off of I-80. You'll see it to the left as you're driving up towards Tahoe. And then to the south of I-80, we have the American River watershed, which starts at the Hellhole French Meadows area of the Sierras. And we actually take water out of that watershed near the old Auburn Dam site here in Auburn. Also want to point out to the viewers that the water that we actually receive from the mountains is probably one of the most pristine water sources you could ask for in the nation. So we are blessed to have that. Part two of this question in my mind also is, what's the obligation that drinking water operations has to the ratepayer? And One of the things we do is we perform studies, which are called sanitary surveys, that allow us to identify potential hazards or contamination sources within these watersheds. So things like off-road recreation, mining, cattle grazing, they all can impact that raw water source. So we have to do what we can, working with either outside consultant firms or laboratories within the area to make sure that we're delivering the best possible product that we can. So, like I said, one of the beauties of these watersheds is it's great water from the get-go. But the second benefit is that we can draw from either water source at a moment's notice. So if we're seeing things happen within one watershed, let's say the Yuba Bear, due to storms or any other potential contamination impact that I mentioned, we have the ability to switch immediately so that we can provide the best possible source to our water treatment plants.
Great. And on that subject, can you talk about how the water gets from those sources in the Sierras to our treatment plants?
Yeah, so within the raw water service areas, the delivery system can include things like our main rivers and streams, like I just talked about, pump stations off of those larger bodies of water, canals, flumes, and pipes. So that's just to name a few, but all of those conveyances allow us to bring water to our 8 treatment plants that we operate to produce the water and get out to the customer.
Great. Now, you mentioned 8 treatment plants. Can you briefly run through where they're located and describe some of the processes that are used if they're different?
Yeah, so our service area from a treatment plant standpoint is broken up into an upper zone and lower zone. So the upper zone is Alta, Monte Vista, Colfax, and Applegate water treatment plants. The Alta, Monte Vista, and Colfax plants actually use a pressure filtration system where we actually are pumping the raw water, well, the semi-treated water at that point, into the filters for the final treatment part of the process. And then Applegate uses a membrane technology. The lower zones, which are the Bowman, Auburn, Foothill, and Sunset water treatment plants, to the lower part of Rockland, they're all using some form of gravity filtration.
Excellent. All right. Well, thank you, Andy, for that recap of the infrastructure and the treatment plants. Before we go, can you give our viewers kind of a preview of what they can hear from your team today?
Yeah, so the viewers are going to hear from Jason Lowe, Water Treatment Plant Operations Supervisor, next. Jason's going to walk the viewers through a virtual tour of the water treatment plant down at Foothill, our Plant 2 water treatment plant. And then after Jason, they're going to hear from Leroy Jones. He's our Distribution Operations Supervisor. And Leroy is going to discuss different parts of the distribution system and how we move water from the plants to the customer's tap. And then finally, Brad Wilkins, our Water Quality Supervisor, will take the viewership through what it takes to maintain federal compliance and how we monitor water quality within the distribution system.
Great. Well, thank you, Andy. As you said, we're now going to go ahead and move on to the treatment process. We have a behind the scenes tour of the Foothill Water Treatment Plant. So we're going to go ahead and dial that up, and we'll go ahead and take a look. Welcome to the Foothill Water Treatment Plant. I'm here today with Jason Lowe, who is the Water Treatment Plant Supervisor. Now, Jason, we just finished a conversation with Andy talking a little bit about the source of our water, kind of the portfolio of the agency, 8 water treatment plants in total. Foothill Water Treatment Plant is the largest. Can you talk a little bit about the plant?
Yeah, so the Foothill Water Treatment Plant is a 62 million gallon per day water treatment plant. We currently have 2 plants on site. Our plant 1 is a 42 million gallon per day backflow treatment process. In that process, we utilize sand to help the suspended solids settle out faster in the water. It's a faster treatment process, newer technology. Our second plant is our plant 2, which is a 21 million gallon per day conventional water treatment plant. The process of that is it's a slower detention time, allowing suspended particles in the water to settle out at a slower rate.
As I understand it, this is the beginning of the treatment process. Can you talk a little bit about where we are and what is going on literally right beneath our feet?
Yeah, so currently we're standing on our grit structure. This is the first step in the treatment process. The purpose of the grit structure is to remove any small rocks, sand, sticks, algae, leaves that flow through this part of the process. There's 2 stages to this. The first stage is we utilize vertical shaft mixers. Basically, they're rotating at a vertical pace to allow the heavier stuff to settle out. The second step is screening. The screens are primarily used to remove any of the leaves or algae that flow through this process. Our goal is to remove that before it gets in the treatment process, and it allows us to treat the water easier.
We're going to go ahead and take a look at plant 2 today. So I think we're ready to move on to the next step. So let's go ahead and we'll take a look.
All right. Yeah.
Okay, Jason, so we've reached plant 2, which is mostly behind us here. But before we get into that, I understand that this is a really important machine that we're looking at here.
Yeah, so this machine right here is what we call a flash mixer. This is a critical component of this treatment process. This is the first stage where we introduce a coagulant chemical into the treatment process. That just allows any of the particles in the water to bind with the chemicals, which in turn allows them to settle out in the next step.
All right, great. Well, let's go ahead and move to the first part.
Okay.
Okay, so after we've introduced the chemicals into the water, kind of what are the next steps?
So the first step we just talked about is the coagulation part. Now we're standing in our flocculation zone. As the water flows to the flocculation area over here, we introduce a polymer to help bind those chemicals together as well. So those are those 2 steps of the coagulation flocculation. These vertical shafts right here spin down, they're impellers that are constantly spinning. So in the first stage, it's going at 75%, next stage 50%, third stage a little slower, it's probably 40%. So that allows the flock to come through, bind together without shearing apart. So you want to go faster and slow it down as you come through this process.
So under here we've got propellers which are moving at different rates to kind of bring everything together as it gets ready to go into the sedimentation bank.
Correct.
All right, well, speaking of the sedimentation bank, here we are. Can you talk a little bit about how much water is in here and kind of what the process is going on here?
Foothill Plant 2, this is a 21 million gallon per day conventional treatment plant. So that's max capacity. So as the water flows from our flocculation zone to the sedimentation basin, as that flock is carrying over, going through this process, it slowly is settling out as it makes its way towards the end of the basin.
And then the last stage of this is the screens. So maybe we can go ahead and move down there. So we've reduced some of the solids, and I can see here that the water right about here gets a lot clearer.
Yeah, so about halfway through the process, you'll start seeing the solids just drop out.
Okay, so by the time we get to the screens, we've pretty much removed all the particles and all the solids, is that correct?
Correct.
Or is that the final part?
Most of the solids are settling out. You're still gonna have some fine impurities coming through, and that will be removed in our filtration step. But as you come through to each side, these are called plate settlers. We install these to give us a larger footprint in this area to treat more water and remove the sludge at the same time. So if you look down our sedimentation basin, you'll see color and it looks a little murkier, but as it flows through our plate settlers and up into these troughs, you notice the water's really clear. Each stage is doing its job to slowly treat this water. The next step would be filtration. From here it flows through these weirs, through the wall, to our 4 filters on the other side of this building. Below us is a tunnel, and below our filters you'll see our valving for our filter process and our instruments we use to monitor the water quality.
All right, let's go take a look.
Okay, let's go. All right, so before we go downstairs, I just wanted to touch bases on the filtration process, and then I'll explain it a little more in depth when we go down there. So this is the top of the filter. As the water's flowing through from the sedimentation basin, it's gonna flow through an anthracite, sand, gravel mixture as it goes through this process. The purpose of filtration is to remove any of the impurities in the water, and then we'll add chlorine for disinfection, and then it goes on to our 10 million gallon storage tank. But let's go ahead and head downstairs, and I'll kind of get a little more in depth on the process. Now we're down below in what we call our filter gallery. This is below our filters. If you look up, you'll see these blue pipes. So this is the effluent to the filters. So as that water flows through the filters from the sedimentation basin, through the filters, we're removing any of the impurities in the water. It comes through this pipe, all the way through here, through this wall, and then after it goes through this wall is where we add chlorine for disinfection. So we want to kill and inactivate any harmful organisms.
Okay, so I see a lot of automation here. Could you talk a little bit about what these devices tell you?
Yeah, so this right here is our TU 5300. So This is measuring the turbidity in the water. So it's just basically, in layman's terms, it's measuring the dirt particles that are filtering through this filter. Our goal is to provide safe, clean drinking water to our consumers. We follow state and federal guidelines to make sure this water is safe to drink. So this is what we monitor 24 hours a day.
So this is turbidity, and what's over here?
So over here is, we also have 2 more turbidimeters here, but we have what we call as our Chemtrek chlorine analyzer. This allows us to analyze and measure how much chlorine we're adding into the water for disinfection. Following state federal guidelines, we set a certain parameter to make sure that that water is safe to drink for our customers.
Excellent. All right, well, let's continue on.
Here we are in the Foothill control room. This plant is staffed 24 hours per day. And from this site, they're able to monitor our 7 other drinking plants throughout the system, utilizing a supervisory control and data acquisition, which we refer to as SCADA. This allows us to make any process changes and or monitor anything that's going on in our treatment plants. So from here, I'd like to take you out to the 10 million gallon clear well and talk about that. So here we are in the last step of the treatment process. We're at our 2 clear wells on site. The one to my right behind me is a 10 million gallon storage capacity clear well. The one behind you is a 1 million gallon storage capacity. Throughout the year, these tanks do fluctuate depending on flow, demand in the system, and then from here it moves on to our distribution system.
Okay, and the distribution system takes this clean water and gets it out to people's taps. So,
Correct.
So the whole process we've been through today, starting up on the grit, moving through coagulation, flocculation, sedimentation, filtration, and disinfectant, that whole process gets us here, and that's the treatment process.
Yes, that's it.
All right, well, thank you so much, Jason,
You're
for
welcome.
the tour today.
The next step of the process is distribution. And joining me now is going to be Leroy Jones. Leroy Jones is our distribution supervisor. And Leroy, thanks for joining us today. Can you, as Jason was explaining, kind of after everything's been treated, we have them holding in the water tanks. The next step is distribution. Could you just explain exactly what does distribution mean?
Yeah, thanks, Ross. Ross, the simplest way is the distribution is the infrastructure that moves the water from the treatment plant to the customer's taps. Basically, it's all the below and above ground piping, everything attached to it, from your pumps to your water tanks to service meters to PRVs. So we even the SCADA and monitoring is part of that also. So we move the water, basically like Andy said, there's a supply line to the treatment plant. Well, once Jason is done treating the water, that clear well becomes my supply. And I take that water and I move it through the distribution. And we also monitor through SCADA, which Jason explained. And yeah.
Excellent. Now, so you had mentioned some of the infrastructure, pressure reducing valves, all the pipelines. A lot of infrastructure to kind of stay on top of. Is there a piece of infrastructure that, let's say, is more critical to ensuring the safe delivery of water?
Yeah, Ross, when you talk about safety, I have to bring up the backflow prevention device. It's one of the most critical components in protecting the drinking water system and keeping the entire system safe. These devices are protects against back siphonage and back pressure. So basically, there's thousands of property. Once that water's on the property, we don't want it back. The cross connection program is the program that we use to identify these properties and then to put in a backflow device. So not only, is it important, for flows and pressures, but it's also for safety. So this is absolutely a critical safety device for the health and safety of the water system and the overall protection of it. And it's a critical program that is very important. Doesn't get the knowledge that it deserves, but it's very, very important.
Excellent. And is there anything, let's say, unique about PCWA's distribution system when we compare it, say, or to a more urban area?
Yeah, Ross. I would have to say, like Andy explained, the multiple water treatment plants, the different methods of treating and moving that through the distribution system. We talked about PRVs. So PRVs is simply a pressure reducing valve. it actually sustains upstream pressure and reduces downstream pressure. So one of the uniqueness of PCWA is that we utilize the natural geography, and so we can use the elevation to move water downhill without installing a lot of pump plants and using a lot of electricity. And so we're a little bit more efficient in that respect. And also we have a lot of interties with all the surrounding partners, and we also wholesale to certain cities. This allows us to move water back and forth between different agencies in times of emergency. Also, I can cut water when I'm a wholesale and supply for PCWA's customers in time of an emergency. So it gives me some options when things are going awry. And yeah, so I would think those things all together make us very, very unique. And on the topic of backflows too, I want you to understand we have over 12,000 backflows in the system. So I'd just like the viewers to think about all the property in the water and what might be coming back to your water system. And I want you to understand that that's why that's important.
12,000, quite a bit. Is there anything else that you would like to share about PCWA's distribution system?
Ross, I would like the viewers to know that it takes a dedicated crew to make a large water system run smooth. And it's not only about flows and pressures and sampling, but it's about monitoring, improving, and protecting. The employees here are required to perform many different job functions. But the best duty that the employees here at PCWA perform is to ensure safe and reliable drinking water. And that makes my job a lot easier. And it's those guys that are out there really serving the public and doing a wonderful job.
All right. Well, thank you so much, Leroy, for that brief overview of the distribution system. The next part of this presentation is to go ahead and move on to water quality and testing. For that, we're going to hear from Brad Wilkins, who is our water quality supervisor. So I'll go ahead and bring Brad up here. Okay, great. And Brad, thanks for being here today. Let's just get to the million-dollar question, which is, how do we know that the water we're delivering to our customers in their homes and their business is safe to drink and high quality water?
Well, in addition to all this dedicated, intelligent, and trained staff and equipment that we have, basically EPA and the State Division of Drinking Water have many regulations we need to meet, which are designed to keep people safe based on all the available science in the field. We test the water before it's treated, so we know what we're treating. We test it during the process, as Jason showed in the video, to make sure it's working and to optimize the process as we go. We test the finished water for most regulated contaminants, which are the ones that are not affected by the distribution system, to make sure that we're sending our customers' water that meets the requirements. We test the distribution system at dedicated sampling stations for things like bacteria and disinfection byproducts and disinfectants. And also in the distribution system, lead and copper is actually tested at targeted representative homes to make sure our corrosion control practices are effective. EPA and the state also have programs for testing contaminants of emerging concern, and that's called the Unregulated Contaminant Monitoring Rule. And that's in order to help evaluate whether new science calls for new standards for those regulations. And overall, we're collecting thousands of samples per year to ensure that we're meeting requirements for drinking water quality. And we have, at least 3 dedicated staff who do just that. They're specialists in testing.
Excellent. Well, do you have any tips for our customers, what they can do around their homes to maintain the high quality of water we're sending to them? And if in doing so, could you also maybe describe some of the, frequently asked questions you receive about water quality?
Sure, Ross. There are a lot of very common concerns, which usually have pretty simple answers, but because people haven't necessarily dealt with the issues before, the dots don't always get connected. And what I'm about to discuss can also be found on our website under the Customer Services tab. If you scroll down from that, there's a link to a water quality page, and the frequently asked questions page is linked at the bottom of that, so anybody can go and check that out at any time. One of the common questions we get is people will think that we've raised the chlorine level or something because they're smelling chlorine all of a sudden. And some people are just more sensitive to chlorine tastes and odors than others. I can assure you that we run the chlorine residual as low as possible to maintain a residual throughout our distribution system to keep the bacteria, keep anything from growing in the system. And we run at about high level is about one part, and that's a quarter of what you can go up to. So we keep it pretty low. But what happens is sometimes if people go on vacation and their water kind of stagnates in their plumbing, the chlorine can start to dissipate. It is a volatile compound, so it starts to dissipate from the water, and that's typically when you're going to smell it. I mean, in our findings, it's not going to be a high chlorine issue. It's going to be more of a lower chlorine issue, or a bathroom that you don't use often. It can cause that as well. So the best thing you can do is just use your cold water tap, flush it out a few minutes, goes away. That's really all it was. Another issue we see quite a bit is, well, mostly in a seasonal, and I'll get to that, but cloudy water. If you fill a glass of water and it comes out looking white and it's just, what is that? Well, if you wait and just watch it, you'll see it dissipate and there's no residue or anything. And that's because it's air bubbles basically. And what happens is that cold water coming down from the snow melt has a high capacity for oxygen. And when it gets put into a pressurized main, it's in suspension in the water. And then when you depressurize it by opening your tap, it comes out of suspension, and all of a sudden you're seeing it, and it's just kind of it's a shock to people who've never seen it before and don't understand what it is. So that's all it is. Nothing to worry about there. Another issue that I've gotten quite a few calls about over the years, and I've seen it in my own homes. I've owned several houses, both within our drinking water systems and in other purveyors' drinking water systems, and I have the same issue no matter where I'm at. But you can get like colored staining, not staining, but like a residue of like pink or black around either the water line in your toilet bowl or your sink drains, your shower drains. And that's basically, it's not in the water. A lot of people will call thinking it's in the water, and it's not. It's an airborne bacteria or various airborne bacteria that are finding a place to live. And the best thing you can do for that is keep disinfecting it, keep fresh water in your toilet bowls, but keep things dry around the sink drains and stuff. But again, it's nothing to worry about with regard to drinking water health. It is simply airborne stuff. And if you live in an area that there's a lot of dirt blowing around and stuff, if you're living near a construction site, or you may see an uptick in that. And I've seen that, over this last 10 years seems like a lot of development. And so there may be more of that lately due to that. Another major one, we get this mostly in the summertime. We get a lot of calls, people saying that the water either tastes like chemicals or like a hose, and that's exactly what it is. What happens is most of us have a nozzle on the end of our hose, and that's a reliable way of keeping water in. And you can forget to turn off your hose bib. And what happens, especially on a hot day, is that the water in the hose heats up, becomes a higher pressure than what's in the rest of the system. You turn on your sink, and that hose water goes right into your tap. So if you ever experience that, that's something that you can look at. Just go around your house, check all your hose bibs, make sure they're off at the bib and not just using the nozzle. There's another common one, or a common slate of issues that can arise, has to do with your water heater. If you have a tank, a regular old-fashioned style tank water heater, which I do, there's several things you want to keep in mind. Main one is the sacrificial anodes. A lot of people don't even know that they're in there, but they do have sacrificial anodes, kind of like your boat motor has anodes on it to keep the boat motor parts from corroding. Your water heater has that too. And if you don't change that out, it's sacrificial, so it goes away, it gets eaten up. And if you don't change that out, your tank can start to corrode itself. and that can cause water color issues when you're running your hot water, and that sort of thing. So one thing you can check to make sure, if it is your water heater that's causing these issues, is check your cold water versus your hot water. If your cold water runs clean, that just tells you the water's good, from the main, and your hot water, you may need to check out your water heater, get it flushed out. That's the other thing I was going to mention about them, is that a lot of people don't realize that you need to, and I'm guilty of it, you need to flush those things out every couple of years or whenever the manufacturer recommends it, because it is, it's a slow point in the water system where it's, it can, anything that is in there, and we take everything out, but it's, there's just tiny mineral content that can build up, but mostly it's going to be corrosion issues from that anode and the corroding of the tank. Another question we get a lot is whether people need a water softener. In short, no, you do not need a water softener in our water system. A lot of times people will be shopping somewhere and a salesman will come up to them and explain to them that there's hard water and that they need to soften it. And these systems can be very expensive, but I want to assure you that our treated surface water system, if you are on that system, you're getting soft water and you shouldn't need a softening filter.
Well, you kind of mentioned it previously, but can you just talk a little bit about the customer confidence report that are available on our website for drinking water?
Sure. So every year I compile all of the testing data that I've gotten throughout the year and put it into a summary, which is a regulated report, an annual report of our drinking water quality. It's called a consumer confidence report. Most people just call it an annual water quality report. And that is always available throughout the year on our water quality page that I mentioned before. So again, you go to PCWA.net and you can hover over customer services and go down to the water quality link, and that'll take you right to the page where almost the first thing on the page is going to be those annual drinking water quality reports.
Okay. And there they can actually look at their specific treatment plant and for their system. Is that correct?
Yes, absolutely correct. And there's a map there too to help you determine what system you're on, or you may notice that in your bill what system you're on. But just make sure you're opening the right document, because as Andy and others have mentioned, we do have 7 different water systems that we manage.
Right. All right. Well, thank you very much, Brad, for that great information. That kind of concludes our formal presentation. We actually have about 10 minutes, which is great time for some audience Q&A. So I'm going to go ahead and just have the panel available. And the first question I have is from Jeffrey. And he asks, is there any value to using a filter at my tap before using as drinking water? So whoever wants to jump with that one.
Sounds like a me question. This is Brad Wilkins.
But Brad.
So in short, I mean, we, as everybody's described, we have very high standards, very good filters and other equipment. So really, no, you shouldn't, unless you have some major plumbing issues. Most of the issues that you're going to see anything at your tap that would cause you to think you might need a filter are going to be plumbing issues. And if you don't have serious plumbing issues that you're not able to solve just by kind of flushing it out till you get fresh water from the main, then you could use a pretty simple filtration system. It doesn't have to be, those softener systems are very expensive, and that's not what we need here. But so you shouldn't need a sediment filter. The one thing that a lot of people have is like a refrigerator filter. And those are basically filled with carbon granules. And what those are good for is if you're concerned about chlorine, which I explained that, we're at the low end of the regulated allowable levels for chlorine, and it's a necessary thing. But some people want their water completely free of chlorine and the disinfection byproducts. And that's what those carbon filters are good for. And they're good for a lot of things, but you can look right on the packages. They come in sink filter form. They come in refrigerator filter form. They come in pitcher filter form. And you can even get whole house filters that use that principle. But really, that's the only thing. If you really want to get rid of the chlorine and byproducts, you can use those.
Hey, Ross, I'd like to chime in on that too.
Yeah, go ahead.
Hey, Brad, I want to make them aware too that, there's also issues, guys, out there. Sometimes, what I find is these under the sink filters and whole house filters, they do not get changed out, and they actually cause you worse issues than if you never had them. So just remember that if you do use one, you must change it on a regular basis. Otherwise, it makes your water worse. Things grow in your filter if you do not change it.
Good point. Thank you, Leroy.
Great. Okay, our next question, I think this is maybe a question for Jason. Regarding the treatment plant tour, what happens to the sediment? Does it have a secondary use or market?
So the sediment, or we call it cemented particles that settle out, they're removed from that basin and moved down to what we call our decant ponds. From there, we process the sludge where we pump it to numerous drying beds. That sludge is then dried off, utilizing sunlight, and then it is hauled off site.
Okay, and I guess second part of that question, are you aware of any secondary uses, or is it?
There is no secondary uses for
Yeah,
it.
Ross, so after we dispose of it, it's a cradle to grave type of product that it goes to a proper landfill, and it's tested vigorously prior to going to the landfill, so that we know we're not harming the environment with any of that.
Okay, great. All right, moving on to the next question. Then I have a question from Neil. It says, is there a target water pressure or pressure range for a residential customer measured where the water line enters the residence?
So yeah, Ross, so all of our mains on the main at the service connection can never be lower than 20. Ross, our standard now is that when we build developments, we try to shoot for 50 for, peak and high demand. So it's different per system. Also, a lot of gravity. That pressure is going to be determined on usage and demand and how high your tank is. So we have some areas where, I have 130, and I have some areas where I only have 30 pounds on the main. So it is different. I can give you anybody that answer on wherever they're at, but it is not the same throughout. And it depends on, are you on a high elevation, living up on a mountain, are you down below? Are you on a pump system, or are you on a gravity system? So there's many factors that go into that. Never below 20, but it's up and down depending on where you are. Our standard now is 50, so we don't design below 50. So I don't know if that answers that question or not, but.
Anything else for anybody to add on that question specifically? Or?
Yeah, I mean, Roy kind of touched on it, Ross. I think the big thing is that if somebody, watching wants to have that checked, if they put in a phone call to our customer services department, Leroy could have one of his distribution operators swing out to the address and put a device on their hose bib and check that for them. So we can provide that information at a moment's notice based on if somebody's interested or not.
Excellent. Thank you. Okay, next question from Jason. It says, do fire hydrants and fire stations use the same treated water we are discussing, or is it a different non-potable water?
Oh,
I can take that, Leroy, if you want to. Yeah, so we have a singular system. So the water that the fire departments are using is treated water. So they, we work very closely with the fire departments. When they test the hydrants for flow, work with new development, everything that runs through the treatment plant is the same water that's coming out of the hydrant.
Okay, and actually on that question, I know that sometimes we've received comments about workers dumping water on the street from the fire hydrant. Could you talk a little bit about why they're doing that?
I'll chime in on that if you want. So a couple things, like Andy touched base on, on fire flows. certain things. We have to do kind of actual sometimes. We can also do on pressure. But the main reason, Ross, is water quality. So what people don't understand is that flushing the system is some of the best water quality work you can do. Okay, even skimming off the top of the tanks. So when they're dead ends or stagnant water, we need to flush this out. I like to touch base on the fire mains too, because we keep extra storage, extra peak, extra everything for emergencies, right? So I want the public to understand water needs to be fresh, just like your food. So you need to move it, make it, move it, and get rid of it. So we have extra storage that isn't really accountable for demand. So yeah, we need to flush fire hydrants, and flushing is water quality.
Excellent. Thank you. Thank you for that. Okay, we've actually got a few questions. A few people asking the same question, and says perhaps someone could speak to fluoridation and why PCWA does not use that practice.
Yeah, I can speak a bit about fluoridation. So the regulations around fluoridation are a little different than a lot of things. So basically, back when they came about, the regulation requires that anybody over 10,000 service connections, and for us that means only our Foothill Sunset system could be affected by this regulation. What they did was they made a waiting list of all these water systems with over 10,000 service connections, and if someone came along with funding for this program of fluoridation, then a water system based on the priority funding list would then have to fluoridate, or they could choose to. But it is expensive. It is an addition of a chemical that is expensive and dangerous for our operators to handle. And it really, while there's a lot of debate over the overall public good of fluoridation with regard to teeth and dental health, it's not an addition to the water that serves any kind of water quality needs. So that's why we haven't gone there. And we're about 26th, I believe, on the list of priority funding.
Exactly.
And I don't believe that list is moving these days. I think the debate is kind of stalling things out in that regard.
Right. Unless anybody has something to add to that, we're coming down to our last few minutes, but I have a question here from Susan. She says, at what stage in the distribution process is testing done? Are there water main pipes that carry water from the treatment plants to the customer monitored for accumulation of contaminants? Inside the pipe, is there a maximum percentage of contaminants allowed? And how often are the pipes inspected for problems?
So I can speak to the testing portion of that. And yes, as I mentioned before, we're testing throughout everything and for different things. The regulations apply to different parts of our the raw water, the in-plant processes. Most things that the state and federal, I mean, this all comes down from federal scientific studies and state scientific studies, that most of the inorganics and volatile organics and pesticides, things like that, are tested right after our full treatment process. And that's because it's been determined over years and years and years of studies that these things don't change as they progress through the distribution system. So the compliance point is basically at our tanks before it goes out to the customers. And then we monitor for all kinds of things, like acute things like bacteria daily. We're taking, a bunch of samples throughout our distribution systems to spot check that everything's going as it should. And while we're doing those bacteria samples, we're also collecting parameters like what's the chlorine level, the turbidity level is very important, pH level is very important, temperature. All of those things, if any of them is like out of whack, we know that we need to look deeper and figure something out. So yes, we are testing all over the place, and there are different regulations based on different science as to what we're testing, why. We do more of it than we're required to, I can assure you of that.
Excellent. Okay. Well, as I said earlier, we are coming to the end here, and I understand I can see we have lots of questions. So I'm going to go ahead and go with one more question here. As I said earlier, if you do have a question that doesn't get answered, just simply copy and paste it into an email to info@pcwa.net. And I will make sure that the gentlemen here get those questions and we get answers to you. But I did have one other question, also from a Jason. It says, is the water distribution system like power lines where you go from thousands of volts down to very low voltage in the home, very high pressure, very high water pressure in the pipes under the road, and then reduced into the homes, or is the whole system low pressure?
So I'll answer that. So no, the system isn't all low pressure. So UPC, Uniform Plumbing Code, above 80 pounds on the main line, the home is supposed to be regulated. And that brings up a great question. If you have over 80 pounds, you probably have a regulator, and that could be causing you some issues, high or low. So yeah, on our system, some of our transmission mains, I talked about PRVs. That's what I'm doing. I'm reducing the pressure to a workable pressure that we want for the lowest elevation. So I don't have 300 pounds down there, but we can send it in very high, and then it'll be regulated at the service for that home. And just a tidbit out there, 80 pounds will start to destroy your appliances. So that's why you want to bring your pressure below that for internal. So I hope that answers the question, but know that the pressure is determined on the plant, the elevation and zone. And then yes, it could be, it will be regulated at your house if it's high.
Okay, excellent. All right, well, we are now at 12:48 as far as I can tell. So we are going to go ahead and kind of wrap up this webinar. But I do appreciate you again for spending your time with us. Hopefully you found the information interesting. I will repeat, if you have a question and you would like it to be answered, please email it to info@pcwa.net. I would also encourage everyone to follow us on social media. If you use social media, we have a Twitter, Facebook account, and we also have videos on YouTube. And this, I believe this webinar will be on our website. So if you have a chance to come back and check it, or you want to share it with someone, we certainly encourage you to do that. Once again, I want to thank you for joining us. And I hope you have a great day and a great rest of the week.